going to talk about model-driven UI optimization, just so everyone's clear on definitions going forward. UI is user interfaces. That's everything from buttons that you see on a screen to keyboards, mice, pretty much anything that you use to interact with a computer. That's what we're talking about here. The model part is part of this thing called a conceptual model. And that's basically this idea that we get in our heads of how we think something should work. And a predictive model is a way of predicting how a person might interact with a particular device. So an example of a model would be something like a save icon. Everybody's saved a program in here, at least I really hope you have at this point in your computer science career. Use a floppy disk, right? The little symbol in the top corner is always a floppy disk. Why? There's no reason for it. We haven't used floppy disks in what, 15, 20 years? That's part of our cultural understanding of what we think the model should be. We see a floppy disk and we think that should mean save. Even younger kids today don't even know what a floppy disk is. They still know that as the save icon. So that's a great example of a cultural idea. And past experience is just the same way. Use computers a lot, always have the exit button in where? Top right, top left. Have you ever used a software that had the exit button in the bottom right hand corner? Had it once, had to use it for a project once, forgot how to close out of it every time I used it. Very annoying. So this paper proposed that we use predictive models to look at UI as an engineering problem. And what that allows us to do is have very objective answers. Traditionally, UI has been more of an artsy thing, do whatever looks nice, looks pretty, and that's great. That's pretty much got us where we are now. But we know we can do better, and this is how we've been able to prove that. So, some of the tools for the job is something called Qt Organizer, or Qt. It's a very popular IDE for designing menus. And these are two very common plugins used in industry. And what they do is they provide real-time feedback on how to make your menus better. And it just makes it very clear what your goals are. But we need to first establish what our goals in UI design is. For optimization, these are the four major categories. You can expand on these a little bit, but these are the major ones. So first off, we have usability. This is, can this actually do what we're looking for? This is, can you type using a mouse? No, not really. So usability is a big part. Learnability, that's can you teach someone to use this? If I start showing you how to use my software, how quickly are you going to be able to pick that up? That's a very important part. You have to think about that whenever you're designing your user interface for any program. Usefulness and usability can get a little misconstrued. Usability, can I use this? Usefulness, should I use this? An example I looked up for this is that PowerPoint itself is a Turing-complete language. There is a paper on it, you can look it up. You can program anything you want using PowerPoint. I would never recommend it to anybody. It uses punch card programming and it's as fast as you can click a button on the screen. Would not recommend it, but you can. So that's where usefulness comes in. Commercial considerations is things like the big buy now button. Right? We all been to websites where they have like 5 buy now buttons. That's something you really need to consider of which one do I need to click. Or if you're designing a website, how do I get them to click on my buy now button? That's really something they really need to consider. And also things like ads. You know, we've all been to a website, they've all got ads on them, we've all used apps. Designing where those go can really go a long way in being an okay UI and a really good UI. Whenever you use a really good UI, it just feels good. You don't really have to think about it, but whenever something's bad, you notice that right away. And that's really from the human touch. No current UI optimizer is perfect. We're only just now starting to really get the idea of using these predictive models to optimize it. And none of them guarantee perfect results in empirical data. None of them offer a 100% guarantee this will make your UI better. So it really needs to be an iterative process, something back and forth between the optimizer and a designer. And that's where you really see your innovation. The optimizer is really good at telling you what you're doing wrong, but only a person can tell you what you're doing right. And figuring out what is optimal, that's up to different scientists than us. That's behavioral scientists, social scientists, neuroscientists, biomechanical, all of the people that collect metrics and then tell us what those metrics are and what the correct answer should be. No UI is perfect. You're going to have to do those balancing acts between those 4 categories. You're going to have to rely on other scientists in soft sciences and hard sciences both to kind of tell you and direct you where you need to go. But hopefully you can use predictive model-based UI optimizer in the future when you're designing your applications to make them better and more usable, and hopefully long term make you more money, which is really good.